Hey guys, I'm Kumar here, back with another video, and in this video I'm be talking about light. So light has fascinated people since a millennia. You see, so many scientists have been trying to formulate their theories based on how light propagates in a medium. Take Newton, take Einstein, take Planck, take Young, take de Broglie, and so many others. The first established theory of light was made by Newton. So what Newton told, that light was made up of small particles called corpuscles, and they propagate very fast in air, water or any medium. So what this happens is that when light comes or obstructs any surface, then as you can see over here, when light, this is one corpuscle, when it obstructs a surface, it gets reflected, and the angle made by the normal with the reflected ray and the incident ray is equal. So by that observation, Newton told that the corpuscles, they get elastically collided with the surface and rebounds back, and hence as the velocity is very high, they maintain the same velocity as earlier. So that explained the law of reflections, and Newton even wrote a book about this. It's called Optics, spelled with a K. And now finally the theory was established that light is a particle nature. At the same time, when Newton was formulating his theory, there was another scientist who was a Dutch physicist called Christian Huygens. Now this scientist was on a different path. He was trying to explain the wave nature of light. But as Newton was kind of the top-notch scientist, after giving his Newton laws, he became very famous. The Christian Huygens theory just got dumped. Newton's theory stayed in part for almost 1 century, that's 100 years. Then finally, one fine day, a young man, a man named Young, Thomas Young, approached the scientific community and showed his experiment. So his experiment was that he took a box, and then there were two slits, rectangular slits very close to each other, and then he covered the whole box, and you could observe when the light passes through what will look like on the other side after reflection. So according to Newton, what you would observe is just you would see regular two rectangular strips. That's what people expected. But the result was quite different. What they found out was quite surprising indeed. So what Young actually observed was that there were circles of light which faded horizontally. So this was quite surprising, because till now, almost a century, people thought that light was particle nature, and this couldn't explain what was observed. So then, if you take light to be as wave nature, then you can tell that the interference of the waves would create such an observation. So then people told that yeah, probably light is a wave. And then there are many experiments conducted by French physicist Augustin, and then there was Maxwell's electromagnetic laws, and they calculated the velocity of light. So all those diffraction and all supported Young's theory. So after a while, they told that light behaves as a wave and not a particle. So then the whole scientific community was settled. But then this drama was not over. The main climax came when Hera and Leonard observed an effect which was called photoelectric effect. So what this means is that when light hits a metal, then electrons are ejected out. And this wave theory failed to explain this, because I'll explain to you why. If you take light as a wave, and then when the wave hits the electron, energy transfer will be slowly, and when the electron reaches the optimum level, it will be ejected out. But that was not quite what was observed. What was observed actually was that the time interval between the light hitting the metal and the electron getting ejected out is almost zero. So that was not quite comparable with the wave theory. But if you take the light as a particle, then whenever the particle hits it, then all the energy will be transferred to the electron instantaneously, and then the electron will be ejected out. So that explains that. And also one more thing is that if you increase the intensity of light, that would basically mean increasing the energy. So that would mean the electrons ejected out would have more kinetic energy. But that's also not true, because if you increase the energy or intensity of the light wave, then the number of electrons ejected is more, but not the velocity, they remain same. So that again points to the fact that light is made up of particles which, when hit the electrons, get ejected by the same energy. So then this created a kind of two-way. One side was Young, who told that light is a wave, and the other side was Albert Einstein, who gave his theory on photoelectric effect and won a Nobel Prize on it. So one was particle theory and the other one was wave theory. So who was right? Was Albert Einstein right, or was Young right? So in the end, finally, what happened is, if you take one phenomenon, it didn't explain the other observations, and if you take this one, it didn't explain this one. So then the scientific community came to a standstill and discussed and finally told that light behaves as both particle and a wave depending upon the circumstances. Like, for example, you take the Young's double slit experiment. For that, it behaves like a wave. Take photoelectric effect, for that it behaves like a particle. So here you can see that light behaves as a wave and particle. Thank you.